Okay, in this video, I'm going to show you another technique for solving, for evaluating limits. And this is one that we don't see a whole lot. I call this combining fractions because if you look at this limit, okay, I have a fraction, actually have a fraction here with x plus 2 in the denominator, and I'm adding two fractions in the numerator, okay? So I want to do this one a little separately, separate video to show you, but let's go ahead and do what normally we do. First step is always check to see what we're substituting in what might work. Okay, so when I substitute a -2 plus 2 in the denominator, I'm going to get a 0. And when I substitute the -2 for this x in the numerator, I have a 1 over -2 plus 1/2, and I can just move that negative anywhere I want to. It really becomes a -1/2 plus a half, and that's a 0. So I have uh, a limit where I have a 0 over 0. So I have to do some algebraic technique to change this around so I can actually substitute in -2. So what I'm going to do is actually combine the numerators. Okay, to combine those two fractions in the numerator. So I'm going to thicken up this fraction right there to show you that's the main division line. Alright, so what I'm going to do is actually add 1 over x plus 1 over 2. Combine them. And then after you do that, you're going to see it's going to go pretty easy after that. Alright, now I'm going to start with an elementary school problem just to illustrate. Okay, when you're in elementary school, you might have been asked to add 1/2 and 1/3. Okay, and you found a common denominator, okay, which is 6. Okay, and you say, well, this 2 right there times 3 is 6, so I multiply 3 times 1. So I change that 1/2 to 3 over 6, and I change that 1/3 to 2 over 6. When I add them, I got 5 over 6. Okay, and that's perfectly well done. Okay, so when I show students, it actually speeds them up a little bit if I do it this way. Same problem. Okay. Alright, what I show students sometimes is I say multiply these two, I get a 3. Then multiply the 2 and the 1, and I get a 2. And then multiply the 2 and the 3, and I get a 6. And when I add these up, add up the numerators, I get 5 over 6. So I get the correct answer that way also. So that's what I'm actually going to do here to combine the 1 over x plus 2 over x, because they do not have the same denominator. Okay? So I'm going to take this 2 times that 1 first, I get a 2, plus, then I'm going to multiply this x times that 1, I get an x, write it in the divide line, okay, and I'm going to multiply the two denominators, that x times that 2, that becomes a 2x. Now I'm not going to do anything to that. I'm going to do something now to this x plus 2 in the denominator. Okay, I'm going to make that a fraction. I'll just drop a 1 underneath there. Okay, so let me thicken up this main division line again. That's the main division line, black one. Okay, so I have a main division line. I have a fraction in the numerator, a fraction in the denominator. Okay, so what this literally means is that fraction at the top is divided by that fraction at the bottom. So I would rewrite it as the top fraction divided by this bottom fraction. Okay, now you're taught in elementary school, when you have something divided by a fraction, you're supposed to leave the first number the way it is, and fraction or not, doesn't matter, and this is a funny looking fraction. If I'm following the rule, I'm going to change that divide to times. I'm going to write the reciprocal of the last fraction. And what I'll see is that even though this 2 plus x and this x plus 2 are in opposite orders, they really are the same, and they would actually cancel out. So I'm going to rewrite this whole limit like this. Limit as x approaches -2. I'm going to write this as 1 over 2x, because I see a 1 that's not canceled, and I see a 2x. Okay, let's try that now. Can I substitute in a -2? Yeah, I can substitute a -2. That -2 right there. put it right where that x is. It's going to be 2 times that negative 2. I get 1 over negative 4. Or negative 1 over 4. That's my limit. That's how you do that type of problem. Okay, let's try another one. Okay, let's do the same thing. We're going to multiply this x times that 1. I get 1x. Now I have a subtract sign this time, so it's very important that I put a subtract sign. Let me move this a little bit over here. Okay, we'll try again. This x times that 1 is an x. I have that subtract sign, so I have to put that sign after that x. Okay, now I'll multiply this 5 times that 1. I get a 5. Okay, alright. I have different denominators. I'm going to have to multiply that 5 and that x. Now I'll get a 5x. Okay, I'll draw my main division line. And in the denominator I have x minus 5. Okay. X minus 5. Okay, I'm dropping 1 underneath that, so I have a fraction divided by a fraction. So now I have x minus 5 over 5x divided by x minus 5 over 1. Okay, alright, I'm going to rewrite my first fraction without any changes. Change that divide to times and flip my second fraction. Okay, and I see that it's going to cancel again. Okay, so I'm going to rewrite my limit as the limit as x approaches 5 of 1 over 5x. We still have a 1 right here, and we still have that 5x. Okay, we're going to substitute our 5 in there. We'll get 1 over 5 times 5. Our limit is 1 over 25. Okay? Alright. Now, sometimes you will have the situation where your fractions will be in the denominator. Okay? Again, these kind of problems don't happen a lot, but it's good to know how to do these. Good to know how, because they do come up every now and then. Alright, so let's do the one on the left. Okay, so my main division line is, again, whoops, just cancel that, it's not what I wanted. Okay, my main division line is right there. Okay, so I have two fractions in the denominator, so use the same technique. Okay, I'm going to start with this 2 times that 1 first. Oh, first of all, alright, let me write my numerator. Okay, I'll get this right. Okay, so let me write my numerator like that. Okay, so I'm ready to do the denominator. Alright, 2 times that 1 is a 2. Alright, here's the subtract sign. Very important to put the right sign. Okay, now we're going to multiply that x times that 1, which is an x. Okay, and we're going to write our another divide line. We'll multiply that x times that 2, which is 2x. Okay, alright, so this time I need to make my top quantity a fraction. So I'm going to write the top at x minus 2. I'm going to drop a 1 underneath that. Okay, draw my divide line. Write my 2 minus x over 2x. Okay, alright, so starting over here on the left, I'm going to write x minus 2 over 1 divided by 2 minus x over 2x. Okay, so I'm going to write the first fraction the way it is, change that divide to times. I'm going to flip the second one. Alright, now this is where you're going to have to be very careful, okay, because I'm going to highlight this. These two are the same two things, but they're in opposite order, and that subtract sign means they're not the same. Okay, when it's adding, it's no problem. An x plus a 2 and a 2 plus an x, that's exactly the same, but an x minus 2 and a 2 minus x are different because we're subtracting, okay? But we can fix this very easy. This is something you just have to be really aware of when you see those subtract signs, okay? What I'm going to do is I'm going to reverse the order of the 2 minus x, but when I do that, I have to put a negative 1 there, okay? And why? Because when I reverse the order, it's really being multiplied by negative 1. And you can check and actually distribute this. That negative 1 times that x and negative x. That negative 1 times that negative 2 is a positive 2. And if I switch just what order, that 2 is still positive for minus x. That's that 2 minus x I had earlier. Okay? So it's very important that when you're subtracting, you find them in different orders. You have to add a negative 1 in there. Okay, so let's go ahead and cancel. We're ready to cancel now. So this x minus 2 and this, let me do a different color. Do pink. This and this cancel. Not the two grays. The gray highlights, they do not cancel. The two pink ones do. So what do we have now? We still have a 2x that did not cancel. We have a positive 1 in this part of the denominator. And we had a negative 1. Well, when we multiply those, we get a negative 1. Okay, so I'm going to rewrite my total limit as this one. Okay, so can we substitute 2? Yes. So we have a 2 times a 2 divided by a negative 1. Our final limit answer is negative 4. Let's try one more like that. Okay, this one's going to be a little easier. I can see right now it's easier because we have those wonderful little plus signs. Okay, so we don't have to worry about what we just got done worrying about. Alright, okay, so let's see. Alright, and then to speed it up, I know I'm going to make my x plus 3 in the numerator a fraction. Let's go ahead and write that as a fraction right now. Alright, let's do the denominator. Let's combine those two fractions. 3 times 1, that's a 3. This time we got a wonderful plus sign. We like that. Okay, we're going to multiply this x times this 1. Okay, and then we're going to not forget, multiply that those two denominators, that x and a 3, and we get a 3x. Okay, so I got a fraction divided by a fraction. I'm going to write the first fraction. Alright, divided by, and sometimes students kind of skip this step and just write the reciprocal at this stage, which would be fine. X plus 3 over 1. Change that to times, put a 3x on the top, put the 3 plus x on the bottom. Don't worry in this case, that plus, x plus 3 and 3 plus x, they're okay. They're the same. They cancel. So, okay, so rewrite my limit as a limit as x approaches negative 3. The function is 3x. I can substitute the negative 3 times a negative 3. I get a negative 9.